Hey guys, this is Mr. Ang, and let's go over lesson 2.2a, time plots. And our learning targets are to, number one, we're going to construct them and also describe this time plot. Construct a time plot of quantitative variable. This is lesson target number 1. Okay, what is it? A definition of a time plot is a scatter plot, because of both those blanks, that displays how a single quantitative variable changes over time. Okay, example number 1, real life examples of time plots here. And what we need to do is we need to circle the quantitative variable for both those graphs and just tell us what each of those graphs tell us. So why is it a single quantitative variable? Well, time will always stay the same, and that's going to be going on the x-axis. Like see that x-axis down here. So the single quantitative variable is actually on this side. Because remember, it doesn't make sense to take the average of years. So this would be kind of a categorical. But the quantitative numerical is over here on that side. Okay, so what does each of these time plots show us? Look at this first one here. I have the date in August of 2015. So these are actually the day numbers. And on the other side, you have the Dow Jones industrial average. That's what that is. It's just the stock markets. And the stock market's actually showing how companies, publicly invested companies, are doing. So here is an example where the newspaper, the internet would kind of show how the Dow Jones is doing. So let's write that. This time plot shows the DJ Dow Jones industrial average over the month of August and its closing price. So it might actually be in table format. So what the table might look like, you might have something like August, and then you have the dates. Right? And then maybe like this point on August 4th, it might have closed around 17,600 points. And maybe then on the 25th, it closed at 15,600 points. So it has this table. It has your X's and Y's. Okay. Let's take a look at this next one. This next graph shows us years. And on the other side, you can read percent of adults using social networking websites. So what does this graph show us? Maybe a website. For a polling organization. Or maybe you're trying to start your own business. That shows what's happening to the graph. We'll learn about that later, but it's going up. So we can say shows growth for social networking over how long? 2004 to 2014-16, so over a decade, or you can even say 12 years or a decade, over a decade. So the big idea here is that it's just showing that change over time. That's why they call them time plots. Okay. So you might be wondering, how do I construct a time plot? And a time plot, it's not that much more different than what we've done before. So let's go ahead and write down these steps here. Where are my steps? Here they are. Number 1. Wait. Number 1, label and scale the time axis, which is the x-axis, the independent, the explanatory. You're going to put the unit of time, whether it's year or date, under the horizontal axis, and place equally spaced tick marks along the x-axis beginning at a friendly time just before the earliest time in the data set and continue until you exceed the latest time. So that's basically, you think about that last part, that's just talking about the range of the data. Okay, what do we got next? Number 2, label and scale the variable axis, which then that will be the vertical or the y-axis. Put the name of the variable of interest to the left of the vertical axis and place equally placed tick marks along the axis beginning at a friendly value slightly less than the smallest value in the data set and continuing until you exceed the largest. So again, you just have the minimum and the maximum will help you, right? Number 3, we can plot individual data points or data values. The order pairs. For each recorded value of a variable, plot a point directly to the right of that value and directly above the time that the value was recorded. And number 4, connect the points. Connect the dots. Connect the points. Now this one you do want to. They also call these line graphs. Starting with the earliest recorded value, connect the dots with line segments, making sure to go in chronological order. Connecting the data points with lines helps emphasize a change over time. So that was page number 1. All right, on page number 2 now, let's do an example here. Baseball, constructing a time plot. While playing with the New York Yankees, Derek Jeter was regarded as one of the best shortstops in baseball. Using the data in the table, construct a time plot by hand to display how the number of home runs he hit changed during his career. Okay, so we're going to have to do this by hand, which is okay. Here's my horizontal and my vertical. The first thing we're going to do is we're going to label and scale the time axis. So here, this is my X. This is, I'm going to mark with a season. And then, well, he played 20 seasons, so let's do, there is 20, and there is 10, so you can do 2, 4, 6, 8, 12, 14, 16, 18. Equally spaced here. And then label and scale the variable axis. So let's label the y now. Let's use a different color, like blue. let's label it the Y. It's the y-axis. These are home runs. Okay. So in this first season, he had 0 home runs. And if I look at the maximum here, I see 24. So you want to go a little bit above and a little bit below. So let's go by 25. And you can choose whatever you like. I'm just going to use 5s, 10s, 15, 20. Third one we said is plot the individual points. Okay, so 1, 0. 2, 10. 3, 10. 4, 19. 5, 24. 6, 15. 7, 21. 8, 18. 9, 10. 10, 23. 11, 19. 12, 14. 13, 12. 14, 11. 15, 18. 16, 10. 17, 6. 18, 15. 19, 1. And 24. Okay. Lastly, we're going to connect the points. We're going to start at season 1, where we had 0 home runs, and draw line segments until we finish. So we'll go left to right. There's my start. And that's our time plot. All right, let's do some lying with statistics. Use the graphs below. How could you use the time plot to lie or convince someone about how the stock markets are doing? So what would I say about this one? Maybe I try to convince you that in the month of August 2015, the Dow Jones Industrial Average started high and ended lower. Okay, let's use some stats we're starting with. A lot of variability. All right. Do you notice how it's fluctuating like Derek Jeter's in the baseball? But something I want you to notice is we said it was okay that you're not starting at 0 there. That is okay. So what do you notice about these numbers? Well, if you subtract them, it's a difference of 2,000. Okay, so maybe I am a conservative financial person saying, hey, don't go into the stock market, you're going to lose your money. Look at this graph. Look how the stock market is going down, trending down, right? You see this negative direction. But if you're a person who's trying to, maybe I'm trying to convince you now. Look at this. Look at the difference here. This one's a difference of 16,000. What if they change? What's the difference between the two of these? It's the scale. People are going to change the scales to make the graphs look different. Does that make sense? This one, what can we say if I say same thing in the month of August? August 2015, the Dow Jones Industrial Average remained consistent or constant, meaning throughout. So here I'm trying to convince you that there's no changes and you should keep your money in it, right? This one we'd probably say has low variability. This one, that's high, right? So many changes are happening. This one we're kind of saying no changes are happening. And that's how you can lie with statistics. Alright guys, I wanted to show you guys how to input a scatter plot or even other graphs we've learned about inside our graphing calculator to get a graph. So let's do Dirt Cheater. So what I'm going to do is first, in the top left it says stat plot, so I'm going to press, that's in yellow, so I'm going to press second, y equals, and it's telling me where to store it. So if you, I'm going to have this one on, and I can actually scroll through and see that there's different types of graphs. Did you guys know what those are? Well, we know what they are, right? Box of whisker box plots, histogram. You can do relative frequencies, but we're just going to choose that one. And then you can just choose your favorite mark. Alright, so let's press done. Okay, so how do I get that in there? So again, we're going to go down to list, which is right next to the left button. So I'm going to press second. And those are the list names, but I haven't put anything in, so I need to press stat, edit, and what we need to edit is our two lists. So I'm going to have to type in 1, and then there you're just going to enter all the numbers. He's a good baseball player. 17, 18, 19, 20. And then I'm going to go back up to the second list. And here now I'm going to enter the number of home runs. So first season 0, 10, 19, 24, 15, 21, 18, 10, 23, 19, 14, 12, 11, 18, 10, 6, 15, 1, and 4. Okay, now I'm going to press, what do I need to press? Zoom. We have a zoom on here? We don't have a zoom. Okay. Alright, I figured it out. It's kind of messed up. So if you click on, I want second stat plot, and if you click on this, in this white rectangle where it says X list and Y list, I can't see it, but I found out that if you kind of scroll your finger, you move it up and down, it'll change it between list 1, 2, whatever you have. So try to get it where X list is L1 and Y list is L2. Maybe just move up a little bit and press done, and you'll notice the changes are there. And now I'm going to press graph. And there is Mr. Jeter's scatter plot. So that's how you do it by the calculator. I'll show you guys later by either Desmos or spreadsheets. All right, page 3, learning target number 2. Describe a time plot of a quantitative variable. So, how do you describe a time plot? Well, when you examine a time plot, look once again for an overall pattern or strong deviations from the pattern. One common overall pattern is the trend. Right? Kind of think like a fashion trend. What are like high school students wearing? I remember years ago, students would put rubber bands at the end of their pants so they can show their cool shoes. That was a trend. A pattern that repeats itself at a regular interval is known as a seasonal variation. Right? It's going to be Halloween, and then you go into the stores and they change it to Thanksgiving and Christmas, so those things change. All right, example number 4. Let's describe what we see here. It says, a time plot shows the number of visitors at the Grand Canyon National Park each month from December 2009 to December 2014. What do you guys notice? Well, seems like they have December's 2010, December 2011, but in December, it seems like it's the low point, right? You only have 100,000 visitors. Does that make sense? And then in the high points, you have like 5 or 6 times more. So we can say during the winter months, less people, or on average, less people are visiting the Grand Canyon National Park. Okay? And then what can we say during those high months? Here's another way of saying it, during the summer months, it appears, so not saying like definitively, but kind of approximately, it appears that make sure you guys are not abbreviating. You can abbreviate on your notes, but don't abbreviate on your quizzes or tests. The Grand Canyon National Park. Visitors average around 650,000. Okay? All right, press pause and you guys try the next one. All right. So would we say that this previous example was, what kind of trend do we have? So the trend that we already described is during the winter, low numbers, summer high, and then we definitely think it's seasonal, right? But look at this example over here. It tells you at the very bottom, the footnote, the price of fresh oranges from January 1990 to January 2000. Okay, so what can we notice here? Some things we can notice is huge jumps here. And why is that? Those are some questions you might have, right? You already see the regular rise. So if you didn't know, it's okay. Oranges, let's use orange. There's definitely strong seasonal, like it's a regular pattern, right? Strong seasonal variation. There are higher prices in the summer. Statistics supports economics. So during summer, people like eating oranges. It's refreshing, but that means high demand. So high demand means increase of prices. They can charge more because it's hard to get. And the supply is low. So few oranges, people really want it. It costs a lot. But then we can also notice some trends, right? So maybe during the winter, when the prices go down, the supply is high, and I don't want to drink orange juice. So the opposite of low demand means that the prices decrease. Okay. Some other things we can note, like what happened during here. Why do the prices jump up hugely? Maybe look at weather patterns and figure out that there was a freeze in Florida in 1991. Right? Or maybe over here, maybe in 1999 there was a hurricane. I don't know if that was the right year, but maybe like Hurricane Katrina wiped out all the orange crops. So there was no supply. Everybody still wants the oranges. And so you need to think about some trends over time. Okay, I'm going to use the computer for this one. All you have to do is just click on that link, and then you just click on 1 month, 6 months, 1 year, and 5 years for the Dow Jones Industrial Average, and you just draw a picture. That's all you have to do. So I'm going to do that. You can press pause. Go ahead and do that on yours, and then we'll compare ours. So if you click on the website, it just takes you to the Dow Jones Industrial Average. And I'm just going to draw my 1 month. Just going to draw a bunch of graphs here. Wow. 1 month, we are at 27,500. The graph kind of starts, right? And then it does something like that. And then if I click on the 6 month, I see more of a positive trend, right? Over 1 year, and this one, we're currently in it, is because of COVID-19. People couldn't go to work, parents couldn't go on a cruise, right? 5 years. And there's your COVID-19. And so those are you can see the years on the bottom there. Right, years are always down here over time, and then the Dow Jones average, the points that is there. All right, let's try the next page. Here are the data. Average tuition and fees charged by public four-year colleges and universities for 1976 to 2005 academic years. Because almost any variable measured in dollars increases over time due to inflation. What is inflation? It is the falling buying power of a dollar. The values are given in constant dollars and adjusted to have the same buying power that a dollar had in 2005. Okay, so go ahead and pause. I want you to create one by hand. And then I'm going to show you guys the answer by creating one with a spreadsheet. All right, my computer screen has the graph we just created. So a couple of questions here to answer. What overall patterns do we see about tuition? So some patterns that I notice, there is generally upward trend, positive trend. That was vocabulary we just learned today. Trend in tuition over time. Some possible deviations from the overall pattern are outliers. Periods of decreasing times, or decreasing changes, and periods of particularly rapid increase, which are present in your plot during which years. Okay. So I just have it looking at the screen, so I don't think there's any outliers. No outliers. I think between 1976 to 1980, the average tuition declined slightly. Something you can notice. Between 2001 and 2005, tuition increased more rapidly than it had been increasing before. Now, I know something you're really eager and I'm really eager to figure out, and we will learn the statistics of how do I predict what would happen in 2020 or whatever year you're watching this video, and was the current model accurate or not? Right. It is now your turn. Example number 7 says your turn. Click on this link and go to the bottom, and you'll have, I think, 4 or 5 options, and choose something other than tuition, because we just did this on the previous problem. And what it is it's a file. You hopefully you can click on it, and you just do the same thing. You copy and paste it and put it into a spreadsheet or Google Sheets just like I did. And it tells you name and keep your spreadsheet somewhere. And you'll do the same thing. Can you calculate it by, can you calculate this one by hand, draw it, this one by spreadsheet, so you can kind of paste a picture here, right, something like that, and then down here, and overall patterns you see. So because there's a couple of options, I won't be showing you any solutions. What you create will be your solution. So that's it for the lesson. See you guys. Problem, Dow Jones over 1 month, 6 months, 1 year, and 5 years. All right, so in that problem, we said make a time plot using a spreadsheet. So with this data, so go ahead and click on this one. And it's going to bring you to tuition. This is from a different professor. And thank you, Professor M. Parker. Don't know who that is. And they have calculated for us the year and the cost of tuition. And so what we're going to do is you're going to just highlight this, just like I'm doing. To the very top. Right click and copy. And then you're going to go to your Google Drive and open up a Sheets. They're called Google Sheets. It's green. And here I'm just going to press, I'm going to right click it and press paste. And then you have all of that there. Okay, so mine got unclicked. So I'm just going to, I have a Mac. And what I'm going to do is, you can either go to the top or the bottom, and I'm going to hold down the Shift button. Hold down Shift, and then click at the top. Left click. Okay, what it did is it highlighted all of my data for me. Okay, so again, you can just click from anywhere, show that one more time, and I'm going to go to the bottom of my list or top, whatever, and then press Shift, and I have all of my data highlighted. Okay, then we're going to go over here. Let's see if my computer can do this. There's this little button that looks like a bar graph right there. It says Insert Chart. Okay, go ahead and click that. And Google does amazing things. So I click on it. We have just gotten a graph, a time plot. Time here measured. Let's see if Google did this correctly. Intervals of every 5 years. Something crazy. I was in college in the year 2000, 2001, and yes, I do remember. Tuition did cost around $4,000 a year, or $2,000 a semester. So you can copy that if you want to, and paste that into your Google document or wherever. I just wanted to show you guys. Let's see. Okay, this one's by state. Again, you can just use Control A. Just paste it, and you have it highlighted. Again, click on it, press Shift, and then you click on that one. And this is my time versus state. I just showed that one tuition. What else we got? Okay, I want to show you the glucose one. It only had the Y coordinates. So, I don't know, you type in day, right? Maybe this is the amount of sugar in my blood. Okay, so it doesn't have a day number. So what you can do is just type in 1, and you have to do the first 3. 2, 3. Computer's running a little slow, just press enter. Okay, then I'm going to click on the 1 there. And then again, hold my Shift key, press left click on the 3, and I'll let go of the shift button. And that little blue button there, I'm going to drag all the way down to the bottom. And this is one of my favorite things about Google Sheets or Excel. It numbers it all for me. That's crazy. I learned this 20 years ago when I was in high school. Okay, so click on, you're going to do the same thing. Click on one of the boxes and you're going to hold down the shift key and then left click on that box. So it highlights all of my data. And I'm going to go over here and into the chart. And if you chose glucose, then that's what it should look like.
Love math. You don't love math?